I open this public meeting of the Doctorate Board of the University of Twente. I would like to express my welcome to all of you. I have of course no idea how many family members are actually listening in. I also would like to welcome the members of the committee. So we have Professor Wijskirchen from Aachen. Then we have Professor Olinga from the University of Groningen, Professor Poelstra from the University of Groningen, Professor Koser from the University of Twente, and Professor Karprien from the University of Twente. Dear candidates, are you ready for this defense? I think you're muted. So are you ready for the defense?
Yes, I am ready.
Good. Then may I ask Professor Wijskirchen to start the opposition?
Okay, hello to everybody. I'm very happy to be in the member committee, and I'm really happy that I could read the work of Mr. Kurniawan. It was very interesting for me. I liked the chapters which you compiled very much, and I have some specific questions to your work. One question is, in your work you show or you discuss that you can incorporate different agents into nanospheres. How do you do that? What methods you use? What is the timeline? Is it expensive? And maybe you can comment on this.
Dear highly learned opponents, thank you very much for your question. Yes, I have been done with the research, the article that I conjugate the fibroblast growth factor 2, as known, also known as basic FGF, conjugated into spions, superparamagnetic iron oxide nanoparticles. What we did, actually, I conjugated biochemically. Yeah, I did with the chemical reaction. Then we characterize using protein characterization to measure that the peptide really incorporated in the spions. We use protein characterization. We use dot plot assay. We use staining Prussian blue assay. Then yeah, we also measure the size, the distribution of particle size. Also, we did in vitro test. Yeah, we did in the human hepatic stellate cells, in the LX2 cells, and finally we did the in vivo test using CCL4 induced fibrosis.
Okay. And is it expensive, this technique, to produce these spheres?
I think about the price, the expensive is relative. I think it's relative, but yeah, I think relative, but yeah, relative, but then I think it's not too expensive.
Okay.
Yeah, actually, we bought spions already. We bought in some of supplier from Germany. Yeah, yeah, I didn't make spions by ourselves, by myself, but we bought the spions from company in the Germany. Then we conjugated chemically with the FGF2.
Okay.
Yeah, I think it's relative about the price.
Okay, in the uptake of these nanospheres into the cells, LX2 cells, how does this work? You put them onto the cells and they will be uptaken by phagocytosis, or how does it work?
Yeah, thank you for your question. Actually, yeah, I haven't done with how the mechanism, but I only with this measure that the FGF2 conjugated spions is already uptake by LX2 cell. But about the mechanism how the FGF2 spions uptake by LX2 cell, yeah, I haven't done explore.
And is it essential that many nanosphere will be taken up, or is it also okay if only some few nanospheres are taken up by the cells to get an antifibrotic effect?
Yes.
You understand my question, huh?
Yeah,
So do you need much of these spheres targeted with FGF2 to get antifibrotic effects? Or is it already sufficient if you have some of these particles incorporated into the LX2 cells? I mean the quantification. How have you quantified how many particles were taken up by the cells?
Yeah, in my paper, around I think around 80 or 90% that the FGF2 spions is taken up by the cells. Yes.
Yes. And maybe my last question in the 10 minutes, how are these particles degraded, or how are FGF2 released by these particles? How can we think about that? Are they degraded by the cells, or is it diffusion out of the nanospheres, or how does the effect that you observed are mediated?
Yeah, actually, we used spions that the surface already linked by polyethylene glycol, PEG. So with the linker by PEG, so this will enhance how the FGF2 spions can penetrate in the cell membrane. So
okay. And if you consider other things than FGF2, which particles or which biological molecules make sense to put into your nanospheres or particles to get an antifibrotic effect? Because you targeted, first of all, hepatic stellate cells, and also macrophages, as I understood it from your work. What can you put into the particles? What should also work, similar to FGF2?
Yeah. Yeah. In my opinion, besides FGF2, we also can incorporate like another peptide to conjugate the spions. In one of my colleague, already also with Ruchi, already conjugated relaxin with spions. So,
Okay.
and
So
another colleague conjugated spions with the chemical compound.
Okay. So, okay. I think this is okay. I think my time has gone. Thank you very much that you answered my question. I'm very happy with that.
Thank you very much.
Thank you, Professor.
Professor Ulrika to continue the opposition.
Okay, thank you very much. Dear candidates, first of all, I'd like to congratulate you very much on your very nice thesis. I also like to extend my congratulations to your supervised team, who I also see sitting there in Twente. And you did a really enormous amount of work in your thesis. I want to ask you something about chapter 3. And in there, you describe the spleen tyrosine kinase as a target. In your chapter 2, you express that this SYK, so spleen tyrosine kinase, is downregulated during HCC. So then when patients have a severe HCC, SYK is downregulated. Is that right?
Yes.
And do you think that because in chapter, chapter 3, on figure 1 on page 61, if you could go to page 61 in your thesis. On the, have you figured it? So figure
in figure
1A. 1A, sorry, 1A, figure 1A on page 61.
Yes.
Your first figure 1A, you show that the gene expression of CYK is upregulated during different stages of liver fibrosis, liver cirrhosis in this case. How did you do this? How did you do this?
Yeah. Do you mean dear highly learned opponents? Thank you very much for your nice question. Yeah, actually, according to the figure 1A, the expression of SYK in the several liver condition. Yeah, actually, we in the liver figure A, we did from the publicly transcriptome analysis. So, yeah, so this is not from experiment, but from transcriptome analysis. So then we made the
you see an increase of the SYK.
Yes. Yeah.
And
SYK increase regarding the severity of the liver diseases, liver damage.
And do you have any idea in which cell type it increased during, in this case, fibrosis, cirrhosis?
In the cell type, so we used for the SYK, we used for the in vitro, we used raw macrophage cell, raw macrophage cell for the cell line. Also, we perform in the bone marrow derived macrophages. So for the SYK, our concern is the macrophages.
So you think also in these patients that the SYK is upregulated, especially in macrophages, or also in fibroblasts or hepatocytes?
Yeah. Thank you. In my opinion, and after I read some of literature, actually SYK is ubiquitously expressed in in hematology. Also, SYK also expressed high expressed in the macrophages, in the hepatocytes, and in the and another cells. Yeah, but in 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 our research, in my research, we perform more in the inflammatory macrophages.
Yes, and then you have distinction between M1 and M2 macrophages.
Yes.
So how did you do that? How did you make them M1 or M2?
Yeah, actually, for this research, I was working more with the in vitro raw macrophages. Then the first, we stimulate the raw macrophages to be M1 macrophages with we induce with the lipopolysaccharide and interferon gamma. Then for the to activated M2 macrophages, we induced with EL interleukin 4 and interleukin 13.
And after that, you put in some drugs, some inhibitors of SYK. I think, or did you did that at the same time?
Yes. Sorry, can you repeat the question?
So when you, because I think also in the same chapter, you also used an inhibitor of SYK.
Yes, we used R406.
Yes, and you also added that to your M1 and M2 cells.
Yes.
And did you do that after you did the adding of the LPS, or did you do that at the same time?
Do you mean that I give intervention with the R406 in the M1 macrophages and M2 macrophages? Yeah, I did in the same time. So yeah, I perform with the 12 well plates. Then we make like unstimulated macrophages, then M1 macrophages and M2 macrophages. Then we give the compound R406. And actually, the R406 can inhibit the M1 macrophages, but for the M2 macrophages, the R406 is not working there.
And why is that the case?
In my according my knowledge, R406 is SYK inhibitor is specifically to inhibit the pro-inflammatory macrophages.
Okay, that's why you see it in these specific macrophages.
Yes.
I started my question with stating that the HCC, that there this SYK is low. One of the things when you have a NASH liver, so when you have a very cirrhotic liver due to NASH, that some of these patients also develop HCC. Do you agree with that?
We concern in the NASH, not until in the HCC.
Yes, I know, but you did some experiments with SYK. Do you think that this could also be a sort of marker for HCC as well? Because you saw in your figure 1A that that increases the gene expression during stages of fibrosis, in this case also of people with NASH. Do you think that when some of these people are going down in SYK, that they then in the end develop maybe some HCCs? Could that be a marker for HCC? Going down YK?
Yeah, I think R406 can be a marker for HCC because in what I read from some literature that actually SYK is involved in many like hematology so I think it's can be proposed to be HCC. Do
we have another time for another question, or?
Yes.
I have. So in chapter 3, you mainly focused on SYK, and in chapter 4, you focused on SRC.
SRC.
So if you compare these two targets, which one would be your favorite, chapter 3 or chapter 4, to in the end see what will be the best anti-fibrotic targets?
Thank you, highly learned opponent, for the nice question. According to my opinion and my research result, yeah, I propose actually from the mechanism, yeah, I will propose for SRC targeted, yeah, but according to the research that already done, yeah, many research already explored more in the SYK. And why I propose SRC, because in the inflammatory process, that SYK is more working in the upstream, so the SRC is more inhibition or more regulation in the downstream pathway. So that's why, yeah, for the next maybe SRC can be more explored.
So Ruti should work on more SRC work, I presume then.
Yeah, in my opinion, according to the mechanism and the position of the pathway in the it's in the inflammatory process.
Okay, then she knows what she has to do in the future. Thank you very much for your answers, and I give the word back to the director.
Thank you very much. May I ask Professor Poelstra to continue the opposition?
Thank you very much, Mr. Chairman. Dear candidates, congratulations on your thesis. I've read it with great pleasure, and it gave me some new insights, which is always a wonderful experience. In addition, your research opened several new opportunities for treatment for liver fibrosis and diagnosis, which is also quite wonderful. Congratulations also to your team of supervisors, Dr. Bansal, Professor Prakash, and Professor Storm. I think you had an excellent team of supervisors there. I do have some questions, in particular on chapter 5, which comes close to my interests. I would like to ask you some questions. You used FGF2 to target hepatic stellate cells for the treatment of liver fibrosis. And I must say it's an elegant approach to reach these cells. And it's a nice follow-up of the studies of the relaxin-coupled spions published by your supervisor, Dr. Bansal. In figure 5, page 141, your strategy is illustrated. First question, one thing that struck me, in your schematic representation, you represent a construct and you indicate that only one FGF2 molecule is coupled to this spion. Is that an artistic representation, or are there more molecules coupled per spion? And do you know how much more then?
Dear highly learned opponents, thank you for your kind words. Also, thank you for your good question. Yeah, according to the figure 5, the representative picture, yeah, actually we are not only have one molecule peptide. Yeah, yeah, we have I already have in the supplement figure that, yeah, we have a recovery around 90% recovery for the peptide FGF2.
But how much molecules of FGF2 are attached to one spion molecule?
Wait.
1, 2, or 20? Do you have any idea?
I have no idea, but I'm sure that not only one.
More than one.
Yes.
There are multiple binding sites. And
yes, I think.
Excess of protein, is that correct?
Yes.
Okay, then you're right, probably more than one, yes. In that same figure, you also indicate the size of this nanoparticle. It's something between 80 and 9 to 5 nanometer. That's approximately the size that can be taken up by macrophages. Is there uptake by macrophages in vivo or in vitro? And what would be the effect of FGF2 in macrophages?
Actually, in my paper with the FGF2 spions, I'm working a lot with the hepatic stellate cells, LX2 cell. I have been done yet with the macrophages cell. So, I think it should be. I cannot say anything, but might be it's in my according to my opinion, might be also can be taken up by macrophages as well, but should be done with the research.
Yeah. But you also did in vivo studies in mice with liver fibrosis, and you saw accumulation in the liver and nice effects, by the way. Did you see uptake in other cells than hepatic stellate cells?
I haven't seen yet in my paper, but I think it can be taken up by another cell, I think in the liver, because
You think you might get uptake in macrophages?
Yes.
That is an option. Okay.
Yes.
And as I said, this is a follow-up of a study also published by Dr. Van Zal, where relaxin was coupled to the spines instead of FGF2. Which compound would be better? Your compound with FGF2 or the compound with relaxin? What do you prefer? Of course, your own compound, but what would be the arguments for that?
Yes. Actually, relaxin already done with my colleague. Also from under supervised by Dr. Ruchi Bansal, and I'm working with the FGF2. In my mind, I think it's depend. But if the FGF2, it's more involved in the wound healing, tissue regeneration, and some of organ development. But relaxin is like a hormone, right? So I think depend on the target that we can reach. So I cannot which one better because I don't know exactly about the what is the relaxin. But according to the FGF2 is fibroblast growth factor 2 that more involved in the wound healing, tissue regeneration, and organ development, and relaxin is some of hormone, peptide hormone.
Okay. So you based on the biological activities of FGF2, you think that the FGF2 constructs are more effective than the relaxin constructs?
Yes, I think.
Okay, I'm very curious to see that in the future when both compounds are tested. By the way, I already said this is an elegant approach to do a therapeutic approach, to have therapeutic effects and diagnostic purposes, to be able to do a diagnosis. For diagnosis, you may need a small molecule in order to prevent background, because a small molecule is rapidly removed from the blood. For therapeutic purposes, you may need a larger molecule to get as much as possible in the target cell. Is it possible to play with the size? Can you reduce the size of spions of your constructs or increase the size? Is that technically possible?
Yeah, I think it's possible. So yeah, basically one of another reason why we conjugated this peptide with the spions, basically we also have a target that this particle, this conjugation between FGF and spions also can be like for the diagnostic. So then yeah, we can engineer that this conjugation can be theranostic. So yeah, might be with the make increase the particle size, also make one of alternative. We already choose the spions with modified with the polyethylene glycol PEG.
So the spions you used in this chapter 5 already contain the polyethylene glycol?
Yes, yes.
Okay.
Yes.
And is it then the size you indicate in figure 5 is well 90 around 90 nanometer? Is it possible to reduce the size by half, for instance? Can you yeah?
Yeah, if thank you for the question. If the question like that, I think it's possible to reduce the particle size.
And because then you would reduce the uptake in macrophages, maybe.
Yes.
Okay, and then I have got a final. I have little time. A final question. These particles, they are going to the fibrotic liver. The scar tissue in this fibrotic liver may be a strong barrier to these spions. Do you think that will be a problem?
I don't think so. Yeah, because in another study that the spions is safe for the regarding the biodistribution. So yeah, I don't think that this conjugation spions can be make a problem in the scar tissue.
Okay, I thank you for your answer, and I give the word back to the rector.
Thank you very much. May I ask Professor Koster to continue the opposition? You're muted, Professor Koster.
Thank you very much, dear rector. Yeah. Dear candidate, congratulations also on your thesis, beautiful work, and congratulations to your also supervisors. I also have some questions. The first one is, so you are working with M1 and M2 macrophages. How does their activity relates to each other? So if is there any, do activity of M1 and M2 occur at the same time, or do they dependent on each other? And how it is regulated? Do you know that? Huh?
Okay, dear highly learned opponents, thank you very much for the good question. Yeah, yeah. Actually, I was working a lot with how to stimulate in pro-inflammatory macrophages, M1 macrophages and M2 macrophages. Yeah, actually, how the condition that M1 and M2 in the body, actually this is like harmony. So if we in the body is more in M1 macrophages, yeah, so the body will adjust to be slow down the M1 and up down the M2 macrophages. Actually that is like harmony. So I think it cannot be spirit exactly.
But when you stimulate them to be M1 by using RPS, I think, how does it affect then your results? Do you also, so you are interfering with that harmony? So how good your method of generating them are, how representative they are to the native situation. So if you force them to be M1 or M2, how do you affect the other one?
Okay.
So if
yes,
you generate, if you force them, yeah. So.
Yeah. Thank you for the nice question. Yeah, as I mentioned before that I induced with to be M1 macrophages. I stimulate with the lipopolysaccharide and interferon gamma, and for the stimulates in the M2 macrophages, I induce with the interleukin 4 and interleukin 13, and we confirmed. I confirmed that then when the M1 macrophages is already there, we confirm with the gene expression. We used a pro-inflammatory marker like INOS, TNF alpha, interleukin 1 alpha, and IL-1 beta. Then we confirm that in the M1 macrophages, those inflammatory marker is highly upregulated. And when for the M2 macrophages, in the anti-inflammatory marker like ERG1, yeah,
I saw the graph. Yeah,
it's high upregulated. Yeah. Yes.
Okay, thank you. And then my next question is on page 64 about your particles, PLGA particles.
Yes.
If you look at figure 4, panel E, so you mentioned that, so we are looking at the phosphorylated and non-phosphorylated SYK.
Yes.
And if I look at the Western blot, I see that M1 plus the drug versus M1 plus the particle. I cannot see the difference between the drug and the PLGA on the expression of level of phosphorylated or non-phosphorylated S5K. But you say that they are different. If you look at the Western blot, they look the same to me.
Yes, thank you for your question. Actually, yeah, if if you, as you can see in the figure 4E, yeah, I think it's different. I think so. I mean, if you see in the SYK, it's the difference little bit. But if SYK, phosphorylation of SYK as compared to SYK, I think it's, the difference is there.
How do you show that? Do you quantify it or?
Yes. Actually, the quantification you can see in the
next graph. Yes.
Yes, in the F.
Yeah,
figure,
in that figure. Yes, but then you quantify by using the program that you look at your intensity, band intensity. Is it like that?
Yes.
Okay, so it's always a discussion how reliable that quantification is, but I understand how you quantify. But my question is, when you give the free drug, where do you dissolve the free drug? In DMSO or alcohol?
Yes,
I dissolve soluble, I guess.
I dissolve the compound in the DMSO.
And did you also do control with cells the same amount of DMSO instead of drug? Do you have that control?
Yes, actually for the control, yeah, we also used DMSO.
Okay, and so you add certain amount of drug and you use as free drug, but in your particles, how much drug do you have? Do you still have the same amount of drug in certain number of particles? So my question is, do you apply the same concentration of drug, free or in encapsulated?
Yes, actually, what I did, The first, we explored in the R406 in the free drug. We perform experiment dose dependently, and we have what is the best concentration there. Afterward, from the best concentration of the free drug there, I incorporated in the PLG nanoparticle. Then we measure the drug efficiency, the drug entrapment of the drug in the PLG nanoparticle. From the drug efficiency, the drug entrapment, then we adjust. Yeah, I remember the drug efficiency is around 40%. So yeah, I calculate that for the treatment in the cell, yeah, we use the equivalent. So between the free
so
drug and the PLG nanoparticle, yes.
Okay, this is very good. And okay, yeah, I'm satisfied. Thank you. I give the word back to the director. Thank you very much.
May I ask Professor Kalperin to continue the opposition?
Thank you, Mr. Rector. Dear candidate, let me start with congratulating you with a beautiful thesis. I read it with great pleasure. I learned a lot in a field which is not entirely mine, but it contains very interesting information. And it also reminded me a little bit of some of my past years in research when I just started my academic career. So I will come back to that later. And I also would like to extend the congratulations, of course, to your supervisory team. But let's go into the science, and that is your interest in the SARC kinase as a potential drug target for treating liver diseases. So if I look at the immunohistochemistry in which you study SARC expression in the liver, it is not entirely clear where exactly do I see the SARC protein? In what cell types is SARC present? Can you tell me a little bit more about that?
Okay. Dear highly learned opponents, thank you for your kind words and your nice question. Yes, yeah. In my thesis, yeah, I'm working with the SYK inhibitor, also SRC inhibitor, and also FGF2 spions. And yeah, for the SYK and SRC, yeah. Actually, we start this research with the in the macrophages. So what we did in the preliminary study, we want to know, actually we make M1 and M2 macrophages and also unstimulated macrophages. Then we perform profiler array. And in what gene that the M1 and M2 is highly upregulated. Then from there, in M1 macrophages, we have two of them, SYK and SRC. So that is to be our baseline to continue the research with explore how the role of SYK and SRC in the macrophages in the in vivo in the liver diseases.
Yes, I understand. So sorry for the interruption, but if I understand the pictures correct and the text correct, you not only see SARC expression in macrophages, but also in other cell types, right? Of the liver, also other cell types. So many immune cells, different types of immune cells, but also the hepatocytes, the fibroblasts. So what is in your opinion the best target? So what is the most relevant cell which you would like to target with your SARC inhibitor?
Okay. Yes. Thank you, dear highly learned opponent. Yeah. In the chapter 4, I think in the SRC kinase. We work a lot, in the not only in the macrophages, we also perform in the hepatocyte, in the LX2 cell. So yeah, that's why for the if your question like that regarding also the liver, that our liver is one of the biggest organ in the gastrointestinal tract. Yeah. I cannot say in what cell that is the best. Yeah, because this still explore and as you know, currently there is no drug that effectively approved from the clinical trial for the treatment of liver diseases. So sorry, I cannot say which the cell that is the best for the this condition, liver diseases, because in the my chapter 4 in the SRC, we work on the macrophages, we confirm in the hepatocyte, we confirm in the L-axil cell, also in the UFAC. It's already almost working there all. So what is the notice for this SRC is promising, but should be careful with the side effect, because the SRC is working more in the cell in the liver.
No. So you state in this chapter that SRC kinase, SAR kinase, is upregulated in liver diseases. And I was just wondering, is this upregulation due to the fact that individual cells start to express more SAR kinase, or is there more recruitment of, for example, immune cells? And we know that immune cells express SAR kinase, and that simply there is more SAR because there are more immune cells. Can you say something about that?
Yes, actually, both of SRC and SYK is ubiquitously expressed in hematology cell. So not only in liver, also in might be you know that about the SYK.
Achterrek, de tijd is verstreken. Thank you, Mr. of Ceremony. I adjourn this meeting of the doctoral board at the University of Twente. The doctorate board of the University of Twente, represented by us, has examined your dissertation and heard your defense. The Committee of Deans has decided, in accordance with Article 17.18 of the law on higher education and scientific research, to admit you to the degree of doctor. I request the first supervisor to carry out the appointed task.
Thank you very much, Mr. Rector. Under the authority assigned to us by law, and on behalf of the doctoral board, I grant you Dhadhang Wahyu Kurniawan, the degree of doctor, and all the rights that are attached to this degree. As evidence of this, we show you this diploma signed by the Rector Magnificus, the Secretary of the Graduation Committee, and your supervisors, validated with the seal of the University of Twente.
Dear learned Dr. Kurniawan, let me congratulate you also on behalf of the university on your acquired dignity. From now on, you have the right to use the title of doctor. This title implies that society can rely on the quality of your judgment, that you will act with integrity and transparency, and that you will communicate independently about the results and the social relevance of your work. Value the doctoralis as an honorable distinction and a well-deserved prerogative. But always remember the obligations imposed by it towards the scientific community and society. Dr. Bansal. Yep.
Dear Dhadhang, dear Dr. Kurniawan, it's my time to read a speech for you. You always ask for. I don't remember how many times, but you always ask me that I should do this job at the end of your defense. And here we are. So first of all, I would like to congratulate you, your family, and your supervisors on this day, on this achievement. And I also thank for their support and patience throughout your PhD journey. And also you, because you had been patient also with me. Well, this is first time I do this, so I didn't know how to start. So I thought, okay, I start from the start when you actually was introduced to me by Kurt and then by Jay. And then we heard that we will have 2 PhD students from Indonesia, and I got the oldest. I was excited because this was my first PhD. But when I saw you, I was like, oh my goodness, he's much older than me. To be precise, you were 10 months older than me. So we share the same date of birth. So we both are born on 21st. But you were already professor, or well, you were already lecturer in Indonesia, and I was just a postdoc and a man and a woman. So I knew from the day one we met, it's going to be challenging for me. And when I saw you speaking, I was like, okay, besides PhD, I also have to teach him English. So it was a journey. I wanted to go in, but I did. It was not too challenging. It was actually, I learned a lot. So you came here, you came with your family, and you adapted well because you came in the cold weather. Your family adapted well. Your kids, you had 2 sons then. They learned to bike. They liked biking. So but you decided to have the 3rd one because your wife, she wanted to have a girl, and you said, well, this is 3rd time we try for a girl, but it turned out to be a boy. And you had 3 sons, and we joined you on the birth of your little son. And it was memorable. It was beautiful to see a little baby, and my whole family was there. And Rana, being a little one, she could carry the little baby. So it was beautiful. And this also will always remind you of the Netherlands, because that's where your 3rd child was born. Well, then I want to talk about your research. So, well, you were trained by me most of the time. We did a lot of experiments together. I did all the animal studies for you, but and when we had discussions, I understood you knew nothing, not about the cells, not about the molecules. I said, what kind of lecturer you are? But anyhow, we still continued, and but when we had the final meeting, we were actually talking like equals. You were telling me what are the problems in the liver diseases, and there are no solutions, and we should think about something. And when I go, I'm going to find a new solution. So you were all full of ideas. So, and then I felt I actually trained a PhD. I made you what you were not, but you became somebody you will become in the future. But well, the one thing which was always struck me was your smile. Whatever happens, you just smile. If your experiment fails, you still smile. When you are nervous, you still smile. And at one point, I was very frustrated. Like, come on, if your experiment fails, it actually failed, huh? You realized it. I told you on your face, you do realize that it failed, but you're still smiling, right? Then I said, but that's a good part that you have. At least you are not stressed. Like every experiment, when it failed, I had to think about it. I was stressed, but you were always keeping calm, which actually was helpful because you could publish with the chapters which you have in your thesis with the calmness. But we went to different conferences together during your PhD. You published 3 excellent papers. You gave oral presentation. Well, nobody will believe here looking at your English, but you did. And you also gave the poster presentations. You won travel grants. You won poster champ award. So I mean, you were very, very much representing everywhere at the national and international conferences. You always accompanied me. We shared a lot of things about life, about me being woman in science, and about you growing further. And you always encouraged me. And what I would say, when you started with me as a postdoc, and you were struggling with your PhD, and I was struggling myself in the academia. So you saw me struggling, and you also saw me growing, and you also always encouraged me. But at the end of today, you will be my first PhD who will defend. And I am so proud that my PhD supervisors are here. So both Klaas and Jay are here. And my current supervisors, Arman and Leon, are here. So I cannot be more fortunate to have this moment when you are defending it with all the people who have always supported me in my career. So to end this, I would like to thank you for having trusted me, for always showing me respect during these years. And I would like to see you coming back in the group as a postdoc, if that is still possible. And I also wish you a very good luck with your career. And I'm sure you will soon become a professor and a dean of your university. And finally, I would like to congratulate and warm wishes to your wife, but also lots of success to your sons. And finally, I just hope that your sons follow your path and they will come to University of Twente for their PhD, and I will be still there. So we will see then. So good luck and many congratulations, Dhadhang.
So Doctor, also congratulations on behalf of the university. I hear this will be the first time that the Dean of a University of Indonesia actually will come and do a postdoc at the University of Twente, as I understood it correctly. So that will happen in 2 years. So I'm really looking forward to it, because she's going to maybe take over some of the responsibilities which I'm doing here. So that means I will see you back. So with that, I would like to close this public meeting of the doctorate board of the University of Twente. No.
Congratulations.
Yeah.
Thank you.
Thank
Thank you so much.
Congratulations.
Congratulations, Dhadhang.
Thank you.
Very nice work.
That we met first time. That was the start of the whole press process. You remember, Dhadhang?
Yes.
2015. We met each other for the first time.
Yeah, I remember.
Yeah, so it's a travel of 7 years. It's a long time.
Yes.
So but there were many obstacles as well. And but I congratulate you also. My gratitude to Ruchi and Jay is high that they picked up our initial contact and enthusiasm to go to Twente, and that you inspired them to also collaborate and supervise you. And I think when I talk with them, they were always satisfied with your enthusiasm for the work. So because it started with us 7 years ago, I would like to say now, I hope you continue and you profit. And indeed, as Ruchi said, one of your major aims with this was to become a dean, to make career in Indonesia. So I hope this will happen at some point, and this whole process will facilitate that.
Now, there is a very small little problem which I just learned about, because the University of Twente doesn't have his address. So we need to have your full address, otherwise you will not get the diploma.
Yeah, so then your dean ambition is over.
So you have to email your complete address where to ship the diploma.
Yes, thank you.
Yeah, you will do that, otherwise you will not become a dean.
Simple as that.
Okay.
Yeah, let's see.
I congratulate you, Dhadhang, and also the team, Ruchi Batzal, Jay, and Gert. Congratulations on this excellent work.
Thank you.
Thank you so much, Prof. Klaas. Actually, one of my lecturer from Indonesia, Dr. Henny Rahmawati, also your student.
Ah,
you remember? Yes.
I didn't know.
Also, congratulations from my side, and I hope you will get a daughter soon. So maybe a daughter will come in the future. This would be great.
So, congratulations, and keep playing football. Don't stop. Probably you come after 2 years and join the team of FC Twente.
Thank you so much, dear Professor Klaas, Professor Olinga, Professor Karperen, Professor Ralph, Professor Koser. Thank you so much, for the evaluating me during my final step in the PhD journey. Also, as I mentioned in my book, many big thanks to Dr. Ruchi Bansal. I spoke to her many times. I am nothing without you. I am nothing without Ruchi. And thank you for Professor Hurt. We met first time in Jakarta. 15th of June 2015. I didn't know him before, but with my confidence, I contact him. I met him. I spoke to him with my English at the time, and then I can meet Dr. Ruchi Bansal there. Also, big thanks to Professor C. Prakash. Yes, you give me a very good scientific mentorship. And the last for the chair, Professor Leon Terstappen, thank you so much. I'm so sorry when we have meeting before. We have problem with the connection, but now I think it's much better because now I use the facility from my university. This is from research center in my university, so I think now it's much better than before. Thank you so much.
Congratulations.
Congratulations.
Congratulations,
Thank you.
Bye.
Congratulations. Bye.
Give my regards to Heni Rahmawati.
So what time?
Yes.
What time is it?
Congratulations.
Thank you, Leon.
Now it's 10:50 p.m.
10:15 p.m. So you still have some drink and to celebrate.
We have small party here.
Have fun. Thank you. Bye-bye.
Enjoy.
Okay.
Enjoy.
Thank you.
Bye-bye.
Thank you. Bye.
Very much.
No?
No, I have many Indonesian that drink alone.
Thank you very much. Run this back. Hello.